which is on conditional probability and the multiplication rule. We had a few examples that I wanted to finish up with you. Just as a reminder, how to find the probability of an event given that another event has occurred. This is called conditional probability, and our notation is P of B given A. Okay. How to distinguish between independent and dependent events. A and B are independent if the probability of B given A is the same as the probability of B, or the probability of A given B is the same thing as the probability of A. And lastly, how to use the multiplication rule to find the probability of two events occurring in sequence, and to find conditional probabilities. Okay, so here we go. So the probability that a particular knee surgery is successful is 0.85. Find the probability that 3 knee surgeries are successful. Okay, so in order to do this, to answer this problem, so we want probability that 3 surgeries are a success. This is essentially probability that the first surgery is a success times the probability that the second surgery is a success times the probability that the third surgery is a success. And this is because the surgeries are, the success of each surgery is independent of the other events. Okay? So the chances for success for one surgery is independent of the chances for the other surgeries. So we can use a general version of our multiplication rule and just multiply the probabilities out. Okay? So we know that the probability of each success is 0.85. 0.85 cubed. So we'll have 0.85 times 0.85 times 0.85, which is going to be equal to 0.614. And this is essentially going to be 61.4. Can you please close the door? Thank you. All right. So let's move to the second example. Sorry for that interruption there. So now we need to find the probability that none of the 3 surgeries is successful. Now here's something that might be tempting, is it might be tempting to say, 1 minus the probability that all 3 are successful. Right? 1 minus the probability that all 3 are success. But no, we can't do that. And the reason why we can't do that is because you don't want to do that. That's wrong. Because the complement of all 3 are successful is not all 3 are successful. So that includes 2 are successful. That includes 1 is successful. And that includes that none of them is successful. So if we want to calculate the probability that none of the 3 surgeries is successful, we need to say, let's do this in black. So the probability that none is successful is going to be the probability that the first one is let's say the probability the first one is a failure, times the probability that the second one is a failure, times the probability that the third one is a failure. Okay, because we can write none is a success. Probability that none is a success is the same thing as the probability that all are failures. Okay, and now what is the probability that the first one is a failure? It's going to be 1 minus 0.85 because the probability of success is 0.85. So 0.15 is going to be the probability of failure, and that's going to be true for each one. 1 minus 0.85, and then 1 minus 0.85, and then 0.15, 0.15. And so now, when we multiply it all together, we'll get about 0.003. 0.003. Okay. So that's going to be our final answer. Now let's go to the last problem. Find the probability that at least one of the 3 surgeries is successful. So here, the probability that at least one is successful is the same thing as 1 minus the probability that none is successful. Because the complement of at least one is successful is that none is successful. And we just calculated this in the last slide. So we'll have 1 minus 0.003, which is 0.997. So we get 99.7%. Let me try to clean this up a little bit. This is equal to 99.7%. Okay. Now, we've got this question here, and I'm going to please pause it and read it because I'm now going to go to the next question. Okay, so find the probability that a randomly selected senior was matched in a residency position and it was one of the senior's top 2 choices. Okay, so here what we want to compute is we want the probability that matched to residency and matched to one of 2 choices. Okay, so now so we're going to call this, so let's see. So we'll call this A, and we'll call this one B. So B is going to be this event right here, which is that you're matched to one of 2 choices, and A is going to be the event that you're matched to residency. So we know from our multiplication rule that the probability of A and B is equal to the probability of A times the probability of B given A. Probability of B given A. What is the probability of A? Which is the probability that you're matched to residency. Let's go back here. And the probability that you're matched with or matched to residency is going to be 93%. So here we see 93% were matched to a residency position. So that means here, P of A is going to be 0.93. And now what is the probability of being matched to one of your 2 top choices, given that you were matched to residency? Well, we can look back here and see that indeed 82% of the seniors matched to a residency position were matched to one of their 2 top choices. So that is 0.82. Okay, so we're going to multiply those together, and we get essentially 0.763. Which is about 76.3% probability. Now let's look at question 2. Find the probability that a randomly selected senior that was matched to a residency position did not get matched with one of the senior's top 2 choices. So here we want the probability that a randomly selected senior was matched to a residency position, did not get matched with one of the senior's two top choices. So not one of top two. Given that you were matched,
it's 21:45
to residency. Okay, and so if we look back, not one of top two is essentially the complement of B.
It's
so here
9:45.
We have that this event is actually going to be B complement, and matched to residency is A. So we're looking at the probability of B complement given A. This is going to be 1 minus the probability of B given A. And the probability of B given A is 0.82. So we have 1 minus 0.82, which should be 0.18, which is 18%. Okay. And in summary, what we've done here is we've used the multiplication rule to find the probability of two events occurring in sequence and to find conditional probabilities. So notice that this business right here of the probability that a particular knee surgery is successful, this is what type of probability? Remember, we've got three types of probability. This is going to be an empirical probability. So let's write that down. Empirical probability. I can't spell empirical. Empirical, I believe. Empirical. Let me just make sure. Oh, no, it's on another slide. Let me see. How do I spell empirical? I believe it's empirical. Empirical probability. Similarly, this example here with the more than 15,000 U.S. medical school seniors. Well, actually, let me go back. So this could be empirical, or it could be empirical, or it could be the subjective probability, right? So that's the one where it's the doctor's it's based on an estimated guess and based on experience and, all of that good stuff. Definitely this one right here with more than 15,000 U.S. medical school seniors applying to residency programs, this is definitely going to be an empirical probability. These are empirical probabilities. Empirical probabilities. Right. Okay. All right. That's it. Thank you.